Binomial theorem. Find one term. What is it? Binomial theorem is an algebraic method of expanding a binomial expression without distributing. Why? Helps in the distribution of IP addresses. Interesting fact. The name rhinoceros means nose horn and originates from Greek. Now, let's take a look at the expansion of the first few powers. Remember, we can use Pascal's triangle to find the coefficients. Let's take a look at the properties. We have already discussed these properties in detail in a different video, so pause the video here if you need a refresher. Now, let's figure out how we can find one term in all this madness. The first part is the coefficient of the k plus 1 first term, and we can find the coefficient by using n choose k, where k is 0, 1, 2, and so forth and so on until n. And that leads us to the k plus 1 first term, where the k plus 1 first term is n choose k times a to the n minus k times b to the k. Now we have another definition of the binomial theorem using the k plus 1 first term. Now let's take a look at the examples we're going to discuss in today's video. Let's take a closer look at example 1a. Let's read the steps. Step 1. Write down Pascal's triangle. Step 2. Write down the first part and descend. Step 3. Write down the next part and ascend. Step 4. Follow order of operations. Now, let's read the question. Use the binomial theorem to find the third term of the quantity of 2x minus 5 raised to the power of 3. Let's write down Pascal's triangle. How many terms do you think we will have? We need to look at the power. Using property 1, we know that there are n plus 1 terms. In this case, n is equal to 3. So we have 4 terms, because 3 plus 1 is 4. 4 terms, 4th row. Now, let's write down the quantity of 2x minus 5 raised to the power of 3 so we can show our work. Now, let's expand this binomial using the binomial theorem. We have our coefficients from Pascal's triangle. We have our a term, 2x, where the powers are descending, and we have our b term, negative 5, where the powers are ascending. Now, let's simplify by distributing those powers, and the first term becomes 2 cubed x cubed, and the second term becomes 2 squared x squared, and the third term becomes 2 to the first x to the first, and the fourth term becomes 2 to the 0 x to the 0. Now, let's simplify any number raised to a power, and the first term becomes 1 times 8x cubed times 1, and the second term becomes 3 times 4x squared times negative 5, and the third term becomes 3 times 2x times 25, and the fourth term becomes 1 times negative 125. Now, let's simplify by multiplying the integers in each term, and the first term becomes 8x cubed, and the second term becomes minus 60x squared, and the third term becomes 150x, and the fourth term becomes minus 125. So the expansion of the quantity of 2x minus 5 raised to the power of 3 is 8x cubed minus 60x squared plus 150x minus 125. Remember, we just want the third term, so our answer is 150x, and that is example 1a. Now, let's take a look at example 1b. The steps have changed. Let's read them. Step 1, write down the formula. Step 2, find k. Step 3, substitute. Step 4, follow order of operations. Now, let's read the question. Use the binomial theorem to find the third term of the quantity of 2x minus 5 raised to the power of 3. Whoa, is this the same question as example 1a? Yes, it is. So we already know the expansion of the quantity of 2x minus 5 raised to the power of 3, and it is 8x cubed minus 60x squared plus 150x minus 125. We already know the answer is 150x, but sometimes it isn't feasible to use the entire binomial theorem to find one term, so that is why we use the formula to find one term. Remember, the formula for the k plus 1 first term is n choose k times a to the n minus k times b to the k. What is k? Maybe if we change the formula from first to third, we will know what k is. So k is equal to 3 minus 1, and 3 minus 1 is 2. Now that we know k, we know n, which is 3, our power. We can substitute 3 and 2 into the formula. And now we have 3 choose 2 times the quantity of 2x raised to the 3 minus 2 times negative 5 raised to the 2. Once again, the 3's come from the power and the 2's come from the k. Now, let's write and choose k using factorials. So 3 choose 2 becomes 3 factorial over 2 factorial times the quantity of 3 minus 2 factorial. We have also subtracted 3 minus 2, which is 1. So now our power of the quantity of 2x is 1. Now, let's take a look at both of our powers, 1 and 2. Do you think having 1 and 2 makes sense? Property 2 says, also, the sum of the exponents is equal to n. Since n, our power, is 3, we are on the right track since 1 plus 2 is 3. Now, let's rewrite our factorials using just whole numbers. Let's simplify what we have so far. n3 times 2 times 1 divided by 2 times 1 times 1 is 3. And the quantity of 2x raised to the power of 1 is itself 2x. And negative 5 squared is 25. So now we have 3 times 2x times 25. And the result of multiplying the whole numbers is 150. So now we have 150x. And that is the answer for example 1b. So we found the third term two different ways. One using the binomial theorem and one using the k plus 1 first term. Which one do you think is easier? Now let's move on to example 2. Let's read the question. Use the binomial theorem to find the eighth term of the quantity of 3x squared plus the square root of y raised to the power of 12. Let's write down this formula, which is n choose k times a to the n minus k times b to the k. What is k? Maybe if we change this formula from first to eighth, we will know what k is. So k is equal to 8 minus 1, and 8 minus 1 is 7. Now that we know k, we know n, which is 12, our power. We can substitute 12 and 7 into the formula. And now we have 12 to 7 times the quantity of 3x squared to the 12 minus 7 times the square root of y to the 7. Once again, the 12's come from the power and the 7's come from the k. Now let's write 12 to 7 using factorials. So 12 to 7 becomes 12 factorial over 7 factorial times the quantity of 12 minus 7 factorial. We have also subtracted 12 minus 7, which is 5. So now our power of the quantity of 3x squared is 5. Now let's take a look at both of our powers, 5 and 7. Do you think having 5 and 7 makes sense? Property 2 says, also the sum of the exponents is equal to n. Since n, our power, is 12, we are on the right track, since 5 plus 7 is 12. Now let's simplify our denominator. So 12 minus 7 factorial becomes 5 factorial. Let's continue to simplify, and 12 factorial over 7 factorial times 5 factorial is 792. And the quantity of 3x squared to the 5th power is 3 to the 5th x to the 10th. And the square root of y to the 7th becomes y to the 7 halves. Now let's multiply any whole numbers raised to a power, so 3 to the 5th becomes 243. Now let's multiply any whole numbers. So 792 times 243 is 192,456. So the eighth term of the quantity of 3x squared plus the square root of y raised to the power of 12 is 192,456 x to the 10th y to the 7 halves. Now let's move on to example 3. Let's read the question. Find the term involving n raised to the 8th power in the binomial expansion of the quantity of 1/2 m plus n squared raised to the power of 10. Now let's write down the formula, which is n choose k times a raised to the n minus k times b raised to the k. What is k? Well, we don't know yet, because we don't have an exact term, just that n to the 8 is involved. But we do know k is equal to 10 minus something. What is that something? Well, let's substitute what we know into the formula to find k. So we have substituted 10 for n, we have substituted 1/2 m for a, we have substituted n squared for b. So how do we solve for k? Remember, n to the 8 is involved. How do we use n to the 8 to solve for k? Well, we set n squared raised to the k equal to n to the 8. Now we can solve for k. N squared raised to the k is the same as n to the 2k. So now we have n raised to the 2k is equal to n to the 8. So k must be 4, because 2 times 4 is 8. Now we can figure out the exact term we're looking for. What term do you think that is? It is the 5th term. We have changed the equation to match what we're looking for. Now let's substitute 4 into the formula. And now we have 10 choose 4 times the quantity of 1/2 m raised to the 10 minus 4 times n squared raised to the 4. Now let's write 10 choose 4 using factorials. So 10 choose 4 becomes 10 factorial over 4 factorial times the quantity of 10 minus 4 factorial. We have also subtracted 10 minus 4, which is 6, so our power of the quantity of 1/2 m is 6. Now let's take a look at both of our powers, 6 and 4. Do you think 6 and 4 make sense? Property 2 says, also, the sum of the exponents is equal to n. Since n, our power, is 10, we are right on track, since 6 plus 4 is 10. Now let's simplify our denominator. So the quantity of 10 minus 4 factorial becomes 6 factorial. Let's continue to simplify what we have so far. So 10 factorial over 4 factorial times 6 factorial is 210. And the quantity of 1/2 m raised to the 6 is 1 to the 6 over 2 to the 6 times n to the 6. And n squared raised to the 4 is n to the 8th. Now let's simplify any whole number raised to a power. So 1 to the 6 over 2 to the 6 becomes 1 over 64. Now let's multiply the rational numbers. 210 times 1 over 64 is 105 over 32. So the term involving n to the 8 is 105 over 32 times n to the 6 n to the 8. And that is example 3. Now it is your turn. So go ahead and pause the video here so you can take your time to answer this question, and I'll show you the result in 3, 2, and 1. Did you get it correct? Awesome. If not, there's always tomorrow.